Welcome to the Java Technocode series, and in this video I'm just going to demonstrate the basics of OOP, and I'm just going to let you see what is actually happening or what actually happens when we talk about OOP in real life. So here I've got a typical question that comes sort of like an interview type question that I'm going to solve for you. So I hope in this video you're just gonna watch as I do and gain the experience of how we use objects in Java. So let's read the question. The question goes like this: create a user-defined data type that represents a given complex number. The data type should have a functionality for multiplying two given complex numbers. So as we see, this is sort of one of those questions that people find it very difficult to actually answer, depending on the level of programming that you're currently in. But without further ado, let's get started. So this is just a my test class that I'm going to use to test my object. So I'm just going to create a new Java object. So here's my project. I'm just going to, within this, I'm going to create a new Java class. In this class I'm just going to name it complex number. So in this class, that's where I'm actually going to create that. Let's just clear this off. So in this class, that's why I'm going to create my data type. So it's going to be a class complex number. So here I'm just going to define floats. Remember that the complex number is supposed to have two parts, sort of like whereby it's the real part and the imaginary part. So my real parts, I'm going to say, is going to be floats, so that I do not actually lose some information if I make it integers. What about if we say decimal point? So I'll just go with float. I think that's the best way. And then ing for imaginary. Then I need to create a constructor. Sorry. Remember, a constructor does not have a return type. It's going to accept two parameters, a real and a float. For a float, two floats for a real and an imaginary number, and then within here I'm going to instantiate some instance variables. This dot real is equals to real. So this keyword here is referring to the object, to the variable, to the object itself, that is the complex number object. So this dot ing is equal to ing, like that. So I'm done with the constructor here. Well, in this part I'll just show you how I'm going to derive the formula for the multiplication of two complex numbers. Suppose we have two complex numbers where we can generalize them by let's say a plus bi and then c plus di, like this. So using the for method, I'm going to expand this. Remember, that will be ac, and then this, that will be as a di, then this, the inner part, that will be bci, and then the last two terms, that will be plus bdi squared, and then that will be ac plus adi plus bci plus, remember this I squared will become -1, so that will be minus bd. Then a group like term, that will be ac minus bd, and then where I'm going to factor out I. That will be AD plus BC, and then I. This will be the general formula, and then from this general formula, I'd like to call these so that you might understand this. I'll call this general complex number this, and then I'll call this other. So I'll just generally try to make this clear here how the formula is going to be derived. So let's say this is prod real, that is the real part of the product is going to be equal to, not A is from this, so say open bracket this dot real, and then times C is equals to other times other dot real, and then minus B. Yes, you know B is the imaginary part of this dot imaginary times D, and then as you know D is the imaginary part of this other dot imaginary, and then for prod imaginary, remember AD, A we know that is for the real, this dot real times D, which means that will be other dot imaginary. Remember there is a plus here, plus, and then BC, B we know that is this dot imaginary times C is equals to other dot real. So these are going to be our formula that we're going to use in the code. So without further ado, let's get back to our NetBeans editor and input these codes and see how we are going to work this out.
Alright, so here at the algorithm, write the algorithm according to what according to the formula that we just derived from the worksheet there. So I'm just going to say public, and then it's going to return a complex number. So say complex number, public complex number, and the method will be calc product. Right, just say where, and then just say where, and then just say calc prod, and then it's going to take a parameter which is of type complex number. Complex number, let's call it other, and then sorry, just need to put some meaning brace here. Right, and then let's unpack that complex number. So we'll just create a float, declare a float variable, and let's call it other real to equal to other dot real, and then let's unpack this other ing is equal to other dot ing. Now let's actually implement our formula that we actually worked on last time. So that was prod real is equal to open bracket, that was this dot real multiplied by other real, right, and then it's separated this dot ing multiplied by other ing, and then we have to order prod ing, which remember these types, they are also floats. So this is line, other real, other real. So like this. Remember, we're supposed to return another complex number, so I'm going to say return type new and new complex number with the parameters put real and Alright, so now what I want to do is to actually overwrite the objects method that is named to string. So let's do this signature is public string, then to string this. So first of all, I'm just going to test my imaginary part of this object. Is this done here? Because I want to render that negative sign that appears. So I'm just going to say this dot real plus img for imaginary part, and then else what I'm going to do is to return. So I'm going to return this dot real plus, and then I'm just going to add this addition sign as this dot img, and then my method to be over right now. So I'm just going to go to my test class and then just create an object, a reference variable, a complex number. Then I'm going to call it cn. This is initiated new complex number. And then we let it be 2 plus 3i, and then let's put another one, complex number. Let's call it cn2 equal to new and then let's call it 2 plus 4i, and then let's print out the multiplication product place. So this is doing out cn dot output cn2. So that will be our product. Let's write exactly. So as you can see, this is our product. So I guess you have understood how the concept of OOP operates in Java. As you can see here, it says like I made a mistake. I didn't put this I that indicates the imaginary part. So I'm just going to modify my class here. And then I'm just going to edit I, and then save here. I'm just going to edit this let's go again and test our class to see if it's working exactly. So as you can see now, it's working.